Hi, welcome to Chili's. Today we're going to learn about collisions. Did you know that collisions happen all around you? And that there are three main types? Not to worry if you didn't. We're going to teach you about them today. Let's go with the video.
So an elastic collision is when two objects collide and they bounce in opposing directions. In this system, momentum is conserved. Now, we're going to show you how an elastic collision works using shoes. Come on. As seen in the previous clip, Imani and I demonstrated an elastic collision as the basketball and the soccer ball collided mid-air, and these two objects separated completely with individual momentums in opposing directions. Had this been a closed system with no outside forces, the total momentum before the collision would be confirmed to be equal to the total momentum after the collision. However, we had gravitational forces acting as an outside force.
Next up, we have partially inelastic collisions. A partially inelastic collision is similar to an elastic collision in that both objects separate completely after the collision. However, in an inelastic situation, kinetic energy is not conserved. We're going to demonstrate this type of collision using a rubber ball against a concrete floor. Let's go see. As seen in the previous clip where I dropped the rubber ball from an initial height, the ball gained momentum as a result of the gravitational forces pulling on it. To explain why there's a difference in kinetic energy before and after the collision, let's go to Imani.
When the ball is held above the ground at an initial height, it has gravitational potential energy. The moment the ball is released, this energy is converted to kinetic energy. Kinetic energy is the energy of motion. After the collision, the ball has less kinetic energy to be converted back into potential energy, affecting the ball's maximum height on a bounce. Let's look at a diagram to help us visualize this process.
So the equation for potential energy is UG equals mg delta y, with this being the height of an object. Remember that. So if you imagine you have your rubber ball at an initial height here, let's say that it has 10 joules. It's then dropped, and as it's falling, that energy is converted from gravitational potential energy into kinetic energy. At the bottom, it still has 10 joules, but then collides with the ground here. In that collision, there's an energy transfer, and that same ball, when it's going back up on a bounce, has less kinetic energy to be converted into potential energy. Therefore, that height that we saw in our equation here has less energy to be used. Therefore, it cannot reach its previous maximum height.
So now we're going to demonstrate a perfectly inelastic collision. This occurs when two objects collide and continue in one direction with the same momentum as before, however, they are one mass. As you saw in the previous clip, the ball of Play-Doh collides with the backpack that's on top of the longboard, and the objects continue in one direction, acting as one mass. Due to the large combined mass of the backpack and the longboard, the Play-Doh is unable to apply a large enough force to make the object move at a high speed. This is because of the Play-Doh's smaller velocity in the beginning. Although the video is in slow motion, I can assure you that it is moving in the clip.
Did you learn something? I sure did. Remember, there's three types of collisions: elastic, partially inelastic, and inelastic. Well, see you next time.
So an inelastic collision is
With
when
this being the height. Okay, wait. So you're just gonna have. So you're just gonna have me in it for.
So who's doing that? Okay. You want to do the intro or the outro? Oh, I've been recording this whole time.
Oh, that was a lot.
Oh,
It's recording already.
Tired.
You are.
Getting sick.
And here we have the wild Darren in her natural habitat.